In this video, we're going to introduce you to graphing on a coordinate plane, which is sometimes called a Cartesian plane, named after René Descartes, the guy who came up with this. So you may see this Cartesian plane. That's just a fancy word for this picture right here, which is called a coordinate plane. So let's start by going over some vocabulary words, and then we'll do some examples. So our first vocabulary word we have over here is x-axis. The x-axis is this line right here. It is the horizontal line that basically tells us how far left or right we want to go. The next vocabulary word we have is the y-axis. The y-axis is this line. It's the vertical line that tells us how far up and down we want to go. And each of those lines is marked off in coordinates. Notice in the x-axis, as we go to the right, we have the positive. It's just like a number line. The x-axis is like your traditional number line. 1, 2, 3, 4, 5 to the right, -1, -2, -3 to the left. And the y-axis is like a number line that's running vertical. So you've got your negatives going down and your positives going up. Now by taking these two number lines and crossing them like this, we create quadrants. That's our next vocabulary word. The whole plane is separated into 4 different parts. The prefix quad means 4. So we've got 4 different quadrants here. And we're going to talk about what these little parentheses with the plus plus means in a second. But let's just focus on this right here, this quadrant. So we've got quadrant 1. So that's anything up here in this upper right hand corner. Quadrant 2 is anything in this upper left. Quadrant 3, lower left, and quadrant 4, lower right corner. Any point that's in the lower right corner. Notice the quadrants, they're using Roman numerals, so there's a 1 there like that. Quadrant 1, quadrant 2, quadrant 3, Roman numeral 3, and quadrant 4. That's common to use Roman numerals to specify the quadrants. Also notice that they're going in a counterclockwise direction. So quadrant 1 is your upper right hand corner, and then it goes counterclockwise 2, 3, 4. The next vocabulary word we have is origin. The origin is the point where the two axes cross, right there, right in the middle. That point is called the origin. Our next vocabulary word is ordered pair. Ordered pair means, first of all, the order matters, and we're going to have a pair of numbers. And so we're going to put those pair of numbers in parentheses with a comma. The first number is going to be the x value, and the second number is going to be the y value. So it's a pair because there's 2 of them. You're going to have 2 numbers, an x and a y. And it's ordered because the order matters. The first number is the x, and the second number is the y. So for the origin, the coordinates of the origin are 0, 0, because we're going 0 to the left and right and 0 up and down. The first number tells you how far left and right to go, the second number up and down. Let's look at the one point that we've got here on this graph right here, 4, -2. 4, -2. So the 4 is the x value. That tells you where to go on the x-axis. So it tells us we're going to go 4 units to the right. We're going to go +4 on the x. And then the y number is -2, so that means we're going to go down 2. So if I start in the middle and I go right 4, down 2, I end up right there. And so the coordinates of this point is -4, 2. Now notice if I switch the order, and go -2, 4, then the x value would be -2 and the y value would be 4. So starting from the origin, always starting from the origin, to find this point, I would go 2 to the left because it's -2, and then 4 up because it's +4. Starting from the middle, so I go 2 to the left and 4 up, and my point would be right there. Now I wouldn't want to draw these lines in, I would just draw the point, but I'm just showing you how I got there. Alright, with a little vocabulary under our belt, let's try some example problems. Let's get rid of this and just bring in a blank graph. And let's plot some points. So let's say we want to plot, let's call the point M is going to be at 3, 4. The point A is going to be at negative 1, 5. The point T is going to be at negative 6, negative 3. And the point H is going to be at 0, 4. Okay, so if I want to find the point M, remember my first number is my X and my second number is my Y. So I'm going to go right 3, up 4. So starting from the origin, right 3, up 4, right there, that point, I'm just going to call it M because I said I'm going to label it M here, is 3, 4. All right, where's the point A? Negative 1, 5. So I'm going to go left 1, up 5. Starting from the middle, left 1, up 5. Now what you might want to do at this point is pause the video and see if you can figure out where T and H would be, and then start it up again and see if you got it right. Or just follow along with me. Try to get there before I do. I'm stalling, so you have a chance here. Alright, so the point T is at negative 6, negative 3. Can you picture where that would be? Negative 6 is going to be left 6, and then negative 3 is going to be down 3. So negative 6, negative 3 would be right here. That would be the point T. The point H is 0, 4. 0 is my X value. That means I'm going to go left or right nothing. Starting from the origin, I'm not going to go left or right at all. I'm just going to go up 4. So here I would go up 4. Right there would be the point H. 0, 4. Let's throw in one more letter. I don't know, what should we spell? Maths. That's, I don't know, is there a plural for math? Let's do negative 5, 0, and change the 0 to the other spot, the Y spot, and see what that looks like. Can you picture where that would be? The X value is negative 5, so I'm going to go left 5, and the Y value is 0, so I'm not going to go up or down at all. From the origin, I go left 5, right there, and I'm not going to go up or down at all, so that's the point S. When you have a 0 for your X value, your point is on the Y-axis. When you have a 0 for your Y value, your point is on the X-axis. So if we wanted to ask what quadrant these points were in, what's the quadrant? M is in quadrant 1. H, remember it goes 1. Remember where it goes? 2, 3, 4. H is in, A is in quadrant 2. T is in quadrant 3. H is not in any quadrant at all. When it lands on the y-axis, it's not in a quadrant. So it's not in any quadrant. You could say it's on the y-axis. And S, similarly, is on the x-axis. It is not in any quadrant at all. So if you'll notice, a point that's in the first quadrant is going to have a positive X value and a positive Y value. I don't know if you remember, you could rewind it and see, but that first picture I had the parentheses with the plus plus, and I told you we'd talk about that in a minute. That's what this is. That's what it was saying, is if your ordered pair has got a positive X and a positive Y, it's going to be positive positive, so it's going to be in the first quadrant. So second quadrant, your X value is going to be negative and your Y value is going to be positive. So a negative X and a positive Y will always put you in the second quadrant. Third quadrant is going to be a negative X and a negative Y to get down here. Negative, negative. The fourth quadrant is going to be positive, negative. So that's what those were about in that last picture. Excellent. Let's try one more example here. Now in this picture, there's already points on the graph, and I would like you to determine the ordered pair that represents each point. So A, B, C, D, you have to come up with the ordered pair that specify the location of each of these points. So why don't you pause the video and try that, and then start up when you have your answers. Alright, let's see how you did. So A, remember I have to put my x value first. This is my y-axis, this is my x-axis. So A is -6 up 5. So -6, 5. It takes two numbers to determine the location of one point. B is over 1, so +1 up 3. 1, 3. Starting back in the middle, C is at 6 and then up nothing. Just sitting right there. So over 6, up nothing. D, I got to go 1 to the left, so that's -1, and then I got to go down 5, so that's -5. -1, -5. Well, I hope this helped you see some examples of plotting points and how to find the locations of their ordered pairs. Graphs are very useful in helping us to understand what's happening in the world in all kinds of situations. And I'd actually like to show you a couple examples of that really fast here. Let's see what I can find here. This is an interesting graph I found. Now this graph's a little bit different than our graph, but it's got the same idea. This is like your x-axis down here. And then this is your y-axis. The x-axis is telling us the years, and the y-axis, there's two different y-axes here. We've got a blue y-axis, which is telling us the daily ridership of bicycle riders in New York City, and then the brown one is a different y-axis over here, is telling us the casualties. So just by looking at this and getting a glimpse at it, we can get an idea of what's happening. The brown is going down over time, that's the casualties, and the blue is going up over time, which is the ridership. So this is a good thing in New York City. I can see that I'm having more riders, bicycle riders, and less casualties. And you could represent each of these points with an ordered pair. For example, this blue point right here, this point right there, would be, looks like 2005 would be the x value representing the year, and the y value, I'd have to kind of go over here and try to guesstimate. I'm going to guess about 100,000. That's not going to fit here. I'm going to be marking all over everything. So in 2005, I had 100,000 riders. That would be the ordered pair that represents this point. We would call it like a piece of data, a data point. And we could take data over time and try to see what's happening. So based on what I see, it looks like the ridership is going up and the casualties are going down. And this graph helps me visualize what's happening there. Let me show you one more. Another common application of graphs is the stock market. I think I found one on the stock market here. There it is. Oh, no, I didn't. I did gas prices. That's another thing we like to track, gas prices. So if just by looking at it, you kind of get an immediate snapshot that we had a big dip in the price and then it shot up. And this picture is generated from plotting points. And those points, the x and the y, the x values are representing the dates down here. And then the y values are representing the price of a gallon of gas. And it's labeled over here. And this has taken us from 2006 to 2008. So we would get the date and the gas price, and we would plot, and we could see a trend of what's happening. There's just countless uses of graphs and being able to display information in a picture where we can really understand what's happening. That is the main use of graphs, one of the main uses of the XY axis and the coordinate system that we've seen. So hopefully you'll get a lot of practice at all kinds of useful and applicable situations where you can use a graph.